Hello, everyone, and welcome to your partner in education, Agile Rank Mate. Today, in this particular episode of SNUSAT Prep, we're going to be looking at some sample questions from the subject of physics. So we'll look at some physics questions and we'll look at how to solve them effectively. So let's start off with our first question for the day. If c, the velocity of light, g, the acceleration due to gravity, and p, the atmospheric pressure, be the fundamental quantities in an MKS system, then the dimensions of length will be same as that of c over g, c over p, pcg, c squared over g. So let's look at this question. Now, for most units, there's something called dimensions, which is basically expressing um, the quantity or unit in terms of the 7 fundamental units in physics. Now, usually we use the SI units and we use the 7 dimensions in order to represent any quantity. Now, sometimes in some questions, you'll be given other quantities, like, for example, the velocity of light, the acceleration due to gravity, and the atmospheric pressure. So these are not quantities that are fundamental to physics. So these are not things like length, mass, or volume, which are fundamental quantities. I mean, length, mass, or time. Volume is, again, a measure of length, so it's not a fundamental quantity. So things like mass, length, time, amperes, these are fundamental quantities, and sometimes you'll be given a question with one or more quantities that are not fundamental, and we consider them to be the dimensions in a particular system, and we need to find the dimensions of another, say, quantity like length or mass in terms of the 3 given quantities. So in this particular scenario, we need to find the dimensions of length using C, G, and P. So we will consider C raised to X, G raised to Y, and P raised to Z as the dimensions of length. Now, in the original system of dimensions, length is represented as m raised to 0, l raised to 1, t raised to 0. Since length is a fundamental quantity of its own, it's only represented by l to the power 1. When we look at speed of light, or c, now speed or velocity is distance over time. So therefore, the fundamental quantities in this case would be m raised to 0, l raised to 1, t raised to minus 1. Then we have acceleration due to gravity, which is g. So this is acceleration. So again, no mass. It'll be distance over time squared. So that means L to the power 1, T to the power minus 2. And finally, we have P, which is atmospheric pressure. Now, pressure is force over area, and force is mass times acceleration, that is uh, mass times distance over time squared. So basically, the dimensions pan out to mass times L to the power minus 1 times T to the power minus 2. So these are the dimensions of the 4 quantities that we will be looking at in the standard fundamental dimension system. Now, we know that C to the power X, G to the power Y, and P to the power Z are the dimensions of length. So we're going to be writing down the equation, the dimensions of L as, now L is represented as m to the power 0, L to the power 1, T to the power 0. And we're going to write the dimensions of C, G, and P, and then, raise them to the powers of X, Y, and Z respectively. So basically now you have m to the power 0, L, T to the power minus 1 raised to X. Then you have m to the power 0, L, T to the power minus 2, Y. And finally, you have m, L to the power minus 1, T to the power minus 2 raised to Z. Now, if you look at it, we're going to use the laws of exponents to get each of them. So 0 times x is 0, 0 times y is 0, 1 times z is z. So for mass, the quantity, the exponent would be z. Now for length, if we look at it, we have 1 times x, 1 times y, and minus 1 times z. So since they all have the same base and they're multiplied together, the exponents are added. So L's exponent becomes x plus y minus z. And finally, for time, it'll be minus 1 multiplied with x, minus 2 multiplied with y, and minus 2 multiplied with z. So basically, you have minus x, minus 2y, minus 2z. Now, since the left-hand side is equal to the right-hand side, we can conclude the following equations. Z is equal to 0, since m raised to z equals m raised to 0, so z will be equal to 0. We also know that x plus y minus z is equal to 1, since the exponent of length on the left-hand side is 1. Now, since we already know that z equals 0, it will be x plus y plus 0 equals 1, which is basically the same as x plus y equals 1. And finally, we have minus x minus 2y minus 2z as equal to 0, since time is raised to 0. We know that 2z is already 0, so we can take negative out, and then it'll be x plus 2y inside the bracket, and that's equal to 0, which we can further simplify to x plus 2y equals 0, because if you take the negative to the right-hand side, it goes in the denominator. 0 negative of whatever times 0 is 0, so there is no change on the right-hand side. So now we know that x plus y equals 1 and x plus 2y equals 0. Let's add them up here. X plus 2y equals 0, x plus y equals 1. We're going to subtract x plus y equals 1 from x plus 2y equals 0, so x and x gets cancelled. 2y minus y is y, and 0 minus 1 is minus 1. So now we know z equals 0, y equals minus 1. Now we'll substitute the value of y in x plus y equals 1. So x plus y equals 1 becomes x minus 1 equals 1. So therefore, x equals 2. So now we know the powers to which C, G, and P are to be raised to. So the dimensions of length in the MKS system will be C to the power 2. So if you look at it, it's C to the power 2, G to the power minus 1, since y is minus 1, and P to the power 0. So these are the dimensions of L. So when you write it in terms of formula, length will be equal to square of speed of light over g. So the dimensions of length is the same as the dimensions of c squared over g, which, if we look at it, is option D. The other options are incorrect because their dimensions would not be equal to L. Now let's look at another question. 7 resistances, each of value 20 ohms, are connected to a 2-volt battery as shown in the figure. You need to find out what is the reading on the ammeter. So if we look at the question, we have 7 resistances. Each resistance is of 20 ohms, and they are connected. If you look at the figure, the resistance are connected in parallel. So, um, so when you have parallel resistance, we find the inverse. We find 1 over R net first, which is 1 by 20 plus 1 by 20 plus 1 by 20. Just add 1 by 27 times. So that will be equal to 7 over 20, which means net resistance will be 20 over 7 ohms. Now, the source of potential difference is a 2-volt battery, so V equals 2 volts. So the net current is V over R net, which is equal to 2 volts over 20 by 7, which is equal to 14 over 20, which we can simplify to 7 over 10 amperes. So the net current is 7 over 10 amperes, and which is a good thing. We can find that out. But we also need to find out how much current passes through each resistor. So current passing through the resistor, to each resistor, by the way, will be equal to, we'll just put that as I, and that is equal to V over R. Now V is 2 volts, still remains the same. R is 20 ohms. So 1 over 10 amperes is the amount of current that passes through each resistor. Now, if you look at the ammeter, okay, let's imagine a circuit. If you look at the circuit, the current starts from the positive terminal, passes through every resistor. So the current gets split up into 7 parts. The first 3 resistors get their current back into the negative terminal without touching the ammeter. However, the other 4 resistors that are to the right of the ammeter will have to pass their current through the ammeter before taking it back to the negative terminal. So basically, if you look at it, the current passing through the ammeter will be 4 times the current passing through a resistor. Since there are 4 resistors to the right of the ammeter and all of their currents has to pass through the ammeter, the current passing through the ammeter is 4 times the current passing through a resistor, since all of the resistors here are the same. So that will be 4 times 1 over 10, which is 4 by 10 amperes. Now, if you look at the options, you can see that option C, 4 over 10 amperes, is the right answer. 3 over 10 means it has to pass through 3 of the resistors, which is incorrect. 1 over 10 is the current passing through each resistor, which is not the amount passing through the ammeter. 7 over 10 is the total current passing through the circuit. So therefore, option C, 4 over 10 amperes, is the right answer. Now let's look at the final question for the day. This one is again on dimensional formulas. The frequency of vibration of a string is given by nu equals p over 2l times f over m square root. Now let me rephrase that. Nu equals p by 2l multiplied to the square root of f over m. Now, p here represents the number of segments in the string. L represents the length. We need to find the dimensional formula of m. Now, um, we don't know whether m is a constant or not. So what we do is, if we look at the formula, nu, which is frequency, equals number of strings over 2l multiplied to the square root of force over m. So in order to compare, let's square both sides just to remove the square root. So nu squared equals p squared over 4l squared multiplied with force over m. Now, we need to find the dimensional formula for m. So in order to do that, all we have to do is, substitute m, take m to the left-hand side and every other quantity to the right-hand side of the equation. So m goes to the left-hand side. The numerator will be p squared f, and the denominator will be 4l squared nu squared. Now, p represents the number of segments in the string, which is just a number. It doesn't have any units, and is what we call dimensionless. Also, 4 is also a regular number. It's dimensionless. So basically, when we look at the dimensions of m, we'll be looking at the dimensions of f. By the way, if you're writing dimensions, make sure to put square brackets because that's what symbolizes dimensions in physics. So dimensions of m would be dimensions of f over dimensions of l squared times the dimensions of frequency squared. So the dimensions of f, force is mass times acceleration, so that's mlt to the power minus 2. Length is just L, so we can just write L with square brackets and square it. So the dimensions for L squared would be, L squared. And frequency. Now, frequency is basically, its dimensions are t to the power minus 1. There's no mass, there's no length, it's just time. Inverse of time is frequency, so therefore t to the power minus 1. But frequency, we're squaring the quantity of frequency in this equation. So we finally get mlt power minus 2 in the numerator, and then in the denominator we have L squared t to the power minus 2. So again, we're going to use the laws of exponents in order to find the final exponents. There's no quantity of m in the numerator, so m stays the same. L to the power minus 1 divided by L to the power, L to the power 1 divided by L to the power 2 would be L to the power 1 minus 2, which is negative 1. And minus 2 and minus 2 cancel each other out. So basically what we're saying is, t to the power minus 2 minus minus 2 is t to the power minus 2 plus 2, which is 0. So the dimensions of m, the quantity that we need to find out, are mass divided by length, and there are no dimensions of time. So therefore, if we look at our options, you can see that there are two options without the time, where t is raised to 0, which are C and D. So the other options A and B are incorrect. If we look at option D, you can see that it's m to the power 0, L to the power 0, t to the power 0. So what this says is that the quantity m is dimensionless. However, we did find out that m has dimensions of mass and length. So therefore, option D is incorrect. The right answer is option C, m L to the power minus 1 t to the power 0. Now that concludes this particular episode of SNUSAT Prep. We hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to Agile Rank Mate, your partner in education. To learn more about our channel, please visit our YouTube website, and you can also hit the notifications button below the video in order to get the latest updates from our channel. So until the next webisode, take care, stay alert, bye bye for now.